So, artificial intelligence. It's everywhere, isn't it? One minute it's a sci-fi trope, robots taking over the world with cold, logical efficiency. The next, it's recommending your next binge watch, translating languages instantly, or writing surprisingly coherent emails. It powers the ads you see, the routes your maps suggest, even helps design the drugs that might save lives. It's simultaneously mundane and mind-blowing, promising revolutionary breakthroughs while sparking deep anxieties. Trying to have a single, simple conversation about AI feels like trying to sip from a fire hose. Where do you even start? Perhaps we start by admitting that the term itself is messy. Artificial intelligence. What does that really mean? It conjures images of sentient machines, self-aware entities pondering their existence. But the reality, at least for now, is far less philosophical. Most of what we call AI today isn't about creating a new form of consciousness. It's about building systems that can perform specific tasks that, previously, we thought required human intelligence. Recognizing patterns, making predictions, finding correlations in massive oceans of data, generating text or images based on learned patterns. It's less about thinking like us and more about doing certain things with startling effectiveness, often surpassing human speed and scale. Think about it. Remember struggling with handwriting recognition software a decade ago? Now, your phone transcribes your messy scrawl with eerie accuracy. Remember bad customer service chatbots? Some are still bad, sure, but others can now hold surprisingly natural conversations, troubleshoot complex issues, and even exhibit a dash of personality. Your email client finishes your sentences. Your photo editing app magically removes photobombers. That song recommendation that feels perfectly tuned to your current mood? That's AI, humming quietly in the background, learning your preferences and predicting what you might like next. It's become woven into the fabric of our daily digital lives, often so seamlessly we barely register its presence. That, perhaps, is its most profound achievement so far, becoming invisible infrastructure. But how did we get here? The dream isn't new. Ancient myths spoke of artificial beings imbued with life. Automata fascinated Renaissance courts. Mary Shelley's Frankenstein grappled with the consequences of creating artificial life centuries ago. The modern quest truly ignited in the mid-20th century. Alan Turing, the brilliant codebreaker, posed his famous question, can machines think? His Turing test, could a machine converse indistinguishably from a human? Set a benchmark, even if it's a deeply flawed one. Then came the Dartmouth workshop in 1956, where the term, artificial intelligence, was officially coined amidst a wave of heady optimism. They dreamed big, solving complex problems, replicating human cognition, within a few decades. Reality, of course, delivered a series of harsh, AI winters. The initial approaches, based on symbolic AI, hard-coding rules and logic, hit a wall. Computers weren't powerful enough. Data was scarce. The problems were just too complex. Funding dried up, optimism froze. But research simmered beneath the surface. Crucially, another approach started gaining traction, machine learning, ML. Instead of painstakingly programming every rule, what if we taught machines to learn from examples? Give them data, lots of it, and let them find the patterns themselves. This shift was fundamental. Then came the accelerants. The internet exploded, generating petabytes of data, the fuel for learning algorithms. Computer hardware underwent its own revolution, especially with the rise of graphics processing units, GPUs. Originally designed for rendering complex graphics in games, their parallel processing power turned out to be perfect for the massive number crunching required by ML algorithms. Suddenly, training complex models became feasible. And then came deep learning. Inspired by the structure of the human brain, Though a vastly simplified version, deep learning uses artificial neural networks with many layers, deep networks. These networks could learn incredibly intricate patterns from vast datasets, recognizing faces in photos, transcribing speech, translating languages with unprecedented accuracy. The pace over the last decade has been dizzying. Remember when image recognition was a party trick? Now, AI systems outperform humans on specific visual tasks. Natural language processing, NLP, went from clunky keyword searches to models like the ones you're interacting with right now. Large language models, LLMs, trained on almost the entire written output of humanity scraped from the web, books, and code repositories, can generate human-quality text, translate languages fluidly, write different kinds of creative content, and answer your questions in an informative way. They don't understand in the human sense. They predict the most statistically probable next word based on a mind-bogglingly complex pattern learned from all that text. But the effect is incredibly compelling, sometimes unsettlingly so. It feels like conversing with a vast, diffuse intelligence drawn from the collective writing of our species. Similarly, generative AI, the ability to create new content, exploded. Tools like DALL-E, Midjourney, and Stable Diffusion can conjure breathtaking images from simple text descriptions, a photorealistic portrait of a cyborg cat wearing a Victorian waistcoat, oil painting style. AI composes music in the style of Bach or Beyoncé, writes poems, scripts, even generates realistic video. It democratizes creation, allowing anyone with an idea to visualize it instantly. It's also raising profound questions about originality, copyright, and the very nature of human creativity. Is it art if a machine paints it? Does it matter? This is where the conversation gets thorny, fast. Because wrapped up in the awe and the utility are genuine, complex challenges. Let's wade into some. Bias. They say garbage in AI, garbage out. AI learns from data created by humans, and humans are biased. Our data reflects historical inequalities, stereotypes, and prejudices. An AI trained on job application data from a biased past might perpetuate that bias, unfairly filtering out resumes from certain demographics. Facial recognition systems have famously struggled with accuracy across different skin tones, leading to real-world harms. AI used in predictive policing could unfairly target minority neighborhoods based on flawed historical data. The danger isn't that AI is inherently biased, it's that it can automate and amplify our existing biases at an unprecedented scale, often operating opaquely, algorithmic black boxes. Mitigating this requires constant vigilance, diverse datasets, rigorous testing, and transparency. It's not just a technical problem, it's a deeply societal one. Job displacement. This is the big anxiety for many. If AI can analyze data faster, write reports, diagnose medical images, drive vehicles, answer customer queries, and even design products, what happens to human workers? History offers some comfort. New technologies often destroy specific jobs but create others. Weavers lost jobs to mechanical looms, but engineers and mechanics gained them. The concern now is the pace and breadth of potential disruption. AI isn't just automating physical labor. It's targeting cognitive tasks, the very jobs many thought were uniquely human and safe. The transition could be brutal for many workers and entire industries.